Good morning, everyone. Mr. Bencharski back here today. We are going to be starting our area of a triangle section. So we've been doing for the last 3 days area of a parallelogram, and now we're going to jump into area of a triangle. But before we get there, we're going to talk a little bit, just recap area of a parallelogram, because this is actually going to help us figure out the area of a triangle. So here is our parallelogram. We have a base of 10, which means this base is also 10, and the height is 8. Remember, this is the side length, not the height. This is the height, the distance from this base to this base. So we use our same formula, area equals base times height. And we fill in the blanks, area equals 10 is the base, height is 8, and 10 times 8 gives us 80 centimeters squared. So there is our area of a parallelogram. Now, I'm going to tell you right off the hop here that the formula to find an area of a triangle is almost identical to the area of a parallelogram. There's just one other step I have to do. Normally when I'm in class, I would say to everyone, okay, I want you to brainstorm, get into a group, think, what do you think the formula might be if I want to find a triangle? But again, remote learning, we're going to be a little bit different here. Here's the thing. Look at my parallelogram. I can turn this into a triangle by just drawing a line there. What I've done here is, I know, forgive my line, I've created 2 triangles, okay? So we might say that a triangle, let's just take this one here, one triangle is half of a parallelogram. So which that means is, if I find the parallelogram, half of it would be a triangle. Well, we already know how to find the area of a parallelogram. It's base times height. So all we need to do to find the area of a triangle is find the base times height and cut it in half, or divide it by 2, which is the same as cutting it in half, because we're looking for a triangle which is half of a parallelogram. Okay, so let's take a look at this one we have here. All right, guys, I have a triangle here, and this one, I want to just make something very, very clear before we get started, and that is, where is the height? Now, in a triangle, there's only going to be one base, and it's going to be relatively obvious where it is. Now, the height is going to be the distance from, in our last, with parallelograms, was the distance from the base to the base. In a triangle, it's the distance from the base to the highest point, okay? So these here, these are side lengths. These are not your height. Okay, they're definitely not your height in this type of triangle. Your height would be the distance from the top to the bottom. Okay, the distance from the top to the bottom. Think of it as an imaginary line. And let's just say for this example that our height is 6. Okay, our height is 6 meters. So here's our triangle. Our base is right here. And our height is the line from the base to the highest point of our triangle. So we use the same formula for all questions with triangles, and that's just base times height divided by 2. Okay, now I know some people might want to write divided by 2. It doesn't matter. In algebra, we often do divided by 2 like this. So let's fill in the blanks. What do we know? Well, we know the base is 5. We know the height is 6. And we know that we're going to need to divide that by 2. Well, 5 times 6 is relatively easy. It's 30. And 30 cut in half will give us 15 meters squared. Remember, we're dealing with area, so it's always meters squared. So, same thing with parallelograms. The only difference here is you need to divide your base times height divided by 2, because a triangle is half of a parallelogram. Half of a parallelogram. Let's do a couple more examples. All right, guys, here's another example. This is a right triangle. It's also known as a right scalene triangle. And let's talk about this one a little bit. So the base is relatively obvious. It's the bottom or flat portion. Now the height, remember, the height in a triangle is the distance from the base to the highest point. Well, would you look at that? Here's the base and here's the highest point. So in this example, this line, this side length is the height. Just like when we did parallelograms, when we did a rectangle, the side length was the height. In a triangle, if it's a right triangle, that is going to be the height is the side length. And let's say in this situation, it is 6 meters. All right, so we're going to apply the same formula we did for the last two examples. And that is the area of a triangle is base times height divided by 2. Because remember, a triangle is just simply half of a parallelogram or half of a rectangle. So once I do the base times height, let's just enter that in. Base is 8, height is 6. Once I do 8 times 6, I'm finding the whole area here, but I only want half. So 8 times 6 is 48 meters, and I want to divide that by 2, and 48 cut in half is 24 meters squared. 24 meters squared. Hopefully I wasn't standing in your way there, guys. I apologize if I was. So remember, the base of a triangle is the bottom, the flat end. You'll really find that easy to find. The height is the distance from the base to the highest point. Now, in a right triangle, it's going to be right on the side length, but in any other triangle, whether it's isosceles or equilateral, it's the distance from the bottom to the highest point. So it's an imaginary line that goes through the middle, or maybe it goes this way. But it's the imaginary line that goes from the base to the highest point. And because a triangle is just simply half of a parallelogram, we find base times height, the same thing to find a parallelogram, and we cut it in half. Now, guys, the practice sheet today is going to be 6 questions just like this. In 2 of the questions, I'm giving you the base and the height. In the second 2, you need to count the amount of squares. Now, let's do this together because this kind of confused people last time. All right, guys, so this one was a little bit confusing. Hang on, I realized it is off kilter here. Let's just bring it up here. Still not high enough. All right. See if we can get it now. There we go. Should be visible. Nope, still a little bit off. Try one more time here. All right, here's another triangle. Got a grid on it this time. So remember, each one of these little spaces is 1 centimeter. I know they're slightly off because I am kind of rough-handing it here. Let's take a look at the base to start. We have 1, 2, 3, 4, 1, 2, 3, 4 squares. So the bottom would be 4 centimeters. Now the height, we want to go the distance from the bottom to the highest point, okay? So let's just go here. We have 1, 2, 3, 4, 5. The highest point would be right there. So there's 5 for the height. Okay, so just make sure you count the grid. So you have 1, 2, 3, 4, 5 squares to the highest point, and 1, 2, 3, 4 squares on the base. So we have area equals base times height divided by 2, because it's half of a parallelogram. The base is 4, the height is 5, and we divide by 2. And I really want you to show this. A lot of people were still not doing this, even though I reminded them. Show your formula. This one should be 4 steps. 5 times 4 is 20. Divided by 2, and 20 divided by 2 is 10 centimeters squared. 10 centimeters squared. So please, guys, show your formula. It should be 4 steps for these ones. There's only 6 questions, so this isn't going to take you very long. I want to do one final example with a right triangle. All right, this is our last example, guys. We have a right scalene triangle here. So let's start with the base. We have 1, 2, 3, 4, 5 squares in the base. So it's 5 centimeters. There would technically be another one here. And the height, remember, it's the side length here. So it's just 1, 2, 3. So 3 centimeters here. So we apply our formula. Area equals base times the height divided by 2. The base is 5. The height is 3. And we divide by 2. 3 times 5 is 15. And 15 cut in half is 7 and 5/10 centimeters squared. Okay, guys, if you have any other questions, please feel free to message me. The practice sheet is 6 questions, just to give you some help with this. Otherwise, that's it, guys. There's not much else to do here. If you need to multiply, please show me your work on your paper. Don't just use a calculator and write in the answer, because I'm going to start deducting marks for that. There are a number of word problems that will come up with area of triangles, so stay tuned for videos part 2 and 3 to help you with your final 2 sheets and get us into mid next week, and then we'll carry on with our final unit, our final part on trapezoids. All right, talk to you soon.